Hello and welcome to this, my video on finding the equation of a straight line graph. My name is Darren from Maths Guru. You already know that if you've seen previous videos, and hopefully you have seen previous videos. But if not, welcome. This is my little corner of the internet to try and make maths as easy and as funky as possible, so that you understand it and can smash it. Now, if you can do me a massive favor, and I ask this every single video, if you can head over to YouTube and subscribe to my YouTube channel, that would be massive. Every single person who subscribes just lets me know that someone out there is actually watching and finding these videos useful. Tell your mates and your teachers as well. All right, the teachers out there are using some pretty ropey stuff, and hopefully I think my stuff is pretty good, and if they know about it, they may well use it instead. And there's also maffsguru.com down there where you can sign up. It's absolutely free, and there's videos all aligned to Cambridge. There are downloadable notes, so everything I write on behind me you can actually download, and life is good. Right, let's get on to the funky stuff. Learning objectives, if you want to know them, are there. Pause the video and have a look over, but let's recap. In the previous video, which I just recorded, and you're probably watching at a completely different time, we have been looking at equations of straight lines, and we know that the equation of a straight line is now given by y equals a plus bx, and that's going to become a little bit clearer in just a moment when we do some more calculator stuff. All right, it's there to try and trick you, but becomes massively important in year 12. So just, but what's important here is that you have to have the y on its own for this to work, and you have to have the x term last. And when I say x term, that's the thing what has an x in it, okay? The number on its own. And again, sometimes we'll try and trick you by making that a 0, but again, maths is just a big fat trick. But when we now have an equation like we've got here, y equals 8 plus 2x, we can now do a lot of stuff with that equation. We know, for example, because we can compare it, the y's are on their own, the a is in the same place as the 8, or the 8 is in the same place as the a, so I now know that's my y-intercept, because my a value is my y-intercept, so my y-intercept is given by 0, 8. And I always write that as a coordinate, right? Because a y-intercept means we go 0 across and we go an 8 up. What do we now notice? That the b is 2. So what does that mean? So that's my slope is equal to 2. But what does that 2 mean? Because normally slopes are given in terms of gradients, because we have an across and we have an up, and across and an up. Well, whenever we have a whole number, the trick is to divide by 1. And then I now know that for every 1 across, in this situation, I'm going to go 2 up. If that was a minus sign, for every 1 across, I would go 2 down. And again, a lot of this stuff to remember, so put it in your summary book. But again, we will try and trick you. If we write it like this, when the y is not on its own, you have to get that y on its own by using some manipulation, which you would have done in a previous chapter. All right, so let's get on with an example. The great thing is once we have the basics, the rest of the work really doesn't change. I can't see how they would make it any more difficult. Right, determine the equation of the straight line graph shown. Well, we know equations have to be in the form y equals a plus bx. Is there anything we can read off of here? Well, yes, we would like our intercept, if you would. And is it giving my intercept? It is. It seems to be going through the point 2 there. So I already know that that's 2. What about my gradient though? How am I possibly going to find my gradient? Well, to be able to find the gradient, you've got to be able to find 2 points on the graph and then probably do the triangle thing through. Well, one of the points that sort of makes sense to have would be this one here. And we're trying to find one that crosses through an actual other coordinate. So for example, I wouldn't choose that point there, because it doesn't seem to go through a nice crossing point, does it? I'm looking for one that goes through one of the crossing points. This one here seems to probably be the best bet. So let's use those 2 coordinates there. How do we do this? Well, we go across, and then we go up. Okay, and that's done a nice curve for me, but we'll leave that one for the moment. So, question is, how many squares cross have I gone? Or how many units have I gone? 0 to 5. Again, I hate saying squares, because if you counted squares there'd be 10 squares. That's not what I mean. Right? We're starting at 0. My thing is ending at 5. And so I now know that that is 5 units across. What about going up? We're starting at 2. We're finishing at 9. So that would have to be 7. I hope. Yep. So we've got 9 to 2, which would be 7. So I'm now going to add my rise divided by my run and times it by x. Now the reason again I'm putting this plus is because my gradient is going up. If my gradient was going down, that there would be a minus. And believe it or not, That's my right answer. Ka-ching, I've done it. Yay. Right, so that's from a graph. That is certainly one way of doing it. There is another way of doing it as well, and that is to sort of build on the knowledge we had last time. If you remember from my last video, we said that the gradient of a graph, and I know I'm using M here, which is a bit weird because I suppose actually that should be B, can be found by taking y2 minus y1 over x2 minus x1. And again, if you don't understand what that means, there is a video on mathsguru.com for you to have a watch. But what we now can introduce is this here. And that is another way of finding the equation of a straight line. So let's look at what this means. Y minus, well, we leave the y as its own because we want our equation to have a y. But what is this y1 business? Oh, well, hold on a moment. It's the same as the y1 here. So this seems to be the y coordinate of a point. M, we now know because we can find M from here. X minus x1. Well, where does this x1 comes from? Oh, a coordinate. So what this is really saying is if I have the gradient of a line and one coordinate on it, I can find the equation. Wow, this is amazing. So let's have a play and try with this example here. All right, find the equation of the line that passes through the points. So I'm now going to use y minus y1 equals, I'm going to use m, x minus x1, where that m is really b. So m, which is really b, is equal to y2 minus y1 on x2 minus x1. Well, where am I going to get this y2 and y1 business from? Ah, my coordinates, which they have given me on my graph. So there we go. We've got 4, 10, and we've got 2, 1. So let's look at y2. Well, y2 is going to be 10 minus y1 is going to be 1. And again, a lot of people get tricked up here or tripped up. Divided by x2, which is 4, divided by x1, which is 2. So what do we have? 10 minus 1, which is 9, on 4 minus 2, which is 2. Now I'm going to leave my gradient like that for this moment in time. Right, so we now know my m value, so I'm going to substitute that in there as 9 on 2. The x stays as it is, and the y stays as it is. They're standard. It's only if it has a x1, y1, x2, y2 do you substitute it in. So let me see. What am I going to do? Oh, I've got to choose a coordinate. Which coordinate? Well, it doesn't matter. You can actually use any of them because it's going to... Anyway, you can actually use any of the coordinates. And I tend to use the one with the smallest numbers or anything with a 0 in it because it makes life a lot easier. But here's a good question for you. Why couldn't I use y equals a minus bx for this question? Why couldn't I use y equals a minus bx? Because we didn't actually see where this line crosses the y-axis. So we can't use that one. So we're probably going to have to use this one here. Or your CAS, which is coming up in a moment. Rightio, so let's see what we've got here. So let's use my coordinate value 2, 1. So there's 2, 1. That's my x1. And there's my y1. So y minus 1 is equal to 9 on 2x minus 2. Now we can't leave it like that because we've got to get the y on its own. So I could write it like this, but again, it's not going to be actually correct. Because what I now have to do is I have to multiply out the bracket. Because if you remember, my equation of a line has to be y equals a plus bx. So I'm going to multiply this out using my algebra. That's going to become 9 on 2x minus, well, 9 on 2 times minus 2 is actually going to be minus 9. And I'm going to add 1. And so therefore, my equation is going to be given by, well, we can do minus 9 plus 1, which is minus 8, plus 9 on 2x. Now that seems really flipping hard, doesn't it? And unfortunately, there could be questions like this in an exam, and you've just got to practice and try and put in the values in the right place. And it does seem like a lot of working out, doesn't it? We've got to find our gradient, and we put that in here, and it's horrible if it's a fraction. But again, just to tell you what I've done here, I've done 9 on 2 times x, and 9 on 2 times minus 2. And if I needed to, I could use my calculator, and I could just bring it up there, and I could go 9 on 2, and I want to times that, please, by -2. Hit enter, and out comes minus 9. So again, use your calculator to try and help you where you can. Just going to make your life a little bit easier. Okay, but that was hard, yeah? Oh, I've got to do another one. Well, let's do another example because, as I say, practice makes perfect. So let's see what we got here. So we got my 2 coordinates. So let's see what we got. We got 2, 4, and we got 3, 10. So let's call that one x1, y1, x2, and y2. Rightio. So let's say my b is equal to y2 minus y1 on x2 minus x1. So y2 is 10, minus y1 is 4, x2 is 3, y2 is 1, 10 minus 4 is 6, 3 minus 1 is, sorry, try that one again, 3 minus 2 is 1. So in this situation, that was nice, my b is 6. Let's write down the other equation. What is it? So we had y minus y1 equals m, which is really b, x minus x1. All right, well, let's use the x1 and y1 that we've got, all right? We might as well use this one here. So we've got y minus y1, which is 4, is equal to m, which is b, 6, lots of x minus my x1, which is 2. Right, well, we can multiply these out. So we can do 6 times x and 6 times minus 2. So that becomes 6x minus 12. I want to get the y on its own, so I've got to add 4 to both sides. So it becomes 6x minus 12 plus 4. So it becomes 6x minus 8, I think. And again, we want to write it in the right order. And again, we've got to be very careful here that that minus sign belongs to the 8. So in which case, my equation becomes y is equal to minus 8 plus 6x. Should we try and do this in a slightly better way or an easier way? Yes, we can use a calculator, which doesn't mean that you don't have to learn how to do this, guys. Unfortunately, if you don't learn, then there can be questions in an exam that you're just not going to be able to answer. But it is a CAS course, so let's see what we can do. Right, let's close down this screen here. And again, I'm going to bring up a graph screen. No, I'm not. I said that every single time. But actually what I'm going to do is I'm going to bring up a lists and spreadsheets. Because what I'm actually going to do is I'm going to put the coordinate values in here. So that's going to become x, and that's going to be y. Now, if you've watched any of my other videos, you'll see me rant about how I need to do this. You have to do the x and y first, or it all goes horribly wrong. Very much so in year 12. So the coordinates I want to put in are written here. So I want to put in 2, 1, and 4, 10. So I'm going to do 2, 1, and then 4 and 10. Now, there's my coordinates in. All I've done is I've just done it in a slightly different way to put my coordinates in. Now, I want to be able to graph these things, right? So, again, the instructions that you see behind me are downloadable from Maffs Guru if you want to put them in your summary book. So now what I'm going to do is I'm going to go Control and plus, and now I'm going to add a data and statistics. A lot of people get very confused because they go, oh, I'm going to draw a graph. Now, the calculator is going to do data and statistics. Now, if you've done yours and you're playing along, then your 2 dots, I can guarantee, will be in completely different places to mine. That doesn't matter, right? Your calculator just takes a rough guess at where it thinks you want them. But what you notice down here is it says click to add a variable. So I'm going to click, and it's giving me a choice of x and y. Okay, then we're plotting coordinates, so let's make that the x. Oh, pretty animation. Click to add the variable here. We want to make that y, and you're like, yay! So now it's plotted the 2 points on there. What I now need to do is say to the calculator, well, can you now draw the equation between those 2 points? And again, when you want your calculator to do something funky, you're probably going to hit menu. Oh, hold on a moment. Maybe it's analyze. Oh. Now, what you're going to ask the calculator to do is a regression. All right? And if we scroll, my calculator's being a bit silly at the moment. But if you scroll, what you should notice is one of those options happens to be a show linear a plus bx. Aha! And again, for year 12, you're going to use that over and over and over and over and over again. So getting used to it now is really important. So if I hit show linear a plus bx, what do I notice? Oh my goodness, there is my equation of my line. Y equals minus 8 plus 4.5x. Now, a word of warning with your calculator, if you're using the TI Inspires, it's stupid. Right, y is equal to, if you had y equals minus 8 plus minus 4.5x, your calculator will quite genuinely put plus minus there. I don't know why, it's clever on one thing, can't do something simple. But so you would just realize that plus and a minus would actually be written as a minus. Right, so just don't get tricked. It's very small. You've got bad eyesight like me, you're in all sorts of trouble. But So there you go. That is how you find your equation of a straight line. Let's turn that off. And let's call it a day for this particular video. Practice makes perfect. If you can, subscribe to me on YouTube. Head over to maffsguru.com and sign up. Absolutely free, with so much stuff on there if you wish to. Or it's free to sign up, I should say. And hopefully I'll see you in another video. If not, please take care. And of course, always stay safe.